revision for Blockchain 101 session. So we started with two games. The first game was to calculate the mean salary of the group who attended the session. And we asked everybody to pass on the paper, and when they do that, add the salary and scribble off the last number. So the idea here was to scribble off the number that you get. Just add your salary so that I can get the sum of salary, and then I'm going to take out the first number, which is the private key. And the idea was that the number that I start with is the number that I'm using for encryption, and with that number I can find out the average salary. But since you don't know the number, you cannot find out the average salary. So the number that I start with, on which you're going to add your salary and we are going to pass this on, that's the private key. And the number that you get, that you use to encrypt your salary, is the public key. So the whole idea about this exercise was understanding asymmetric encryption. Public key is the key that is with the public, which they can use to encrypt the data, to take part into the computation. Private key is the key which is with the person who is like the admin, or who is having the final outcome, who can decrypt the data. So the idea is that anybody can decrypt the data, anybody can encrypt the data, but only the one who has private key can decrypt the data. The complexity of the algorithm keeps on increasing, which is going to come later. We can have the same algorithm go more complex if we want to. The next game that we played was calculating the hash and creating a block for yourself. So when you want to rate somebody, when you want to rate the instructor, you're going to start with the last hash, the number of characters in your count, the rating, and that would be the final hash. So for the first block, hash is 1. My name is Joshi, so it's 5. I give a rating of 10, so it's 1 plus 5 plus 10. So 16 would be the new hash. So that was our simplistic block, and we added more complexity to the block later. Hashing was the most important part. It's also called the proof of work. It's also called the mining. Hashing complexity we increased by having the user calculate the prime number for the nth block. So the second block would calculate the second prime number. The third block would calculate the third prime number. So those were the two games for the day. The game where we are creating the hash was critical, because with the help of that we understood that creating of new hash is like mining, and mining is like a validation that you actually worked on that block, because it's going to take time for me to mine that block. So this was the game, and there are two blocks here. Here the first block is with a past hash of 1, name is Joshi, and rating is 10. So the next hash becomes 16. And the next block would start with the past hash of 16, name is XXX, rating is 1. So it's 16 plus 3 plus 1, 19. So this is a very simple block, and these two blocks are joined by the blockchain. Then we went and checked out the website where we were practicing the blockchain, and we saw that if we change the data, the blocks become red. And we saw that nonce is a block number that is used to create the hash, and the hash always starts with 40. So this is how a block would look like in a blockchain. They generally have a timestamp, and the thing that joins two blockchain is the hash, and hashes start with zeros. We practiced a game where I made the hash end with 0. So mining is calculation of the hash. The mining is very complex in Bitcoin and other cryptocurrency, and the chances of success is very low. That's why they have to use GPU and all those high computation to find out the hash. If we were to look at the Bitcoin blockchain, then we can go to the Bitcoin ledger and see that. So the Bitcoin has got a block number, we have hash, we have nonce, and with the transaction we have the transaction fee, and we have new Bitcoins that are generated. Then we looked at the Python implementation. We saw that we have two blocks. The green block is the blockchain info, and the yellow block is the the hash calculation. The hash calculation is you take the string of everything and add it and pass it through this SHA algorithm, which is going to decrypt it to find out the new hash. The new hash would have a 0 in the starting, and whatever we want, we can put that constant. Then we looked at dApp to do the solidity example, and we tried to launch our own currency, but the whole idea was that the front end would be the same as it is, but the back end would turn to Ethereum blockchain and not the traditional SQL which we are using right now. So we did Rinkeby blockchain in the class, and we downloaded the wallet, which was part 2 of the class. So I hope this was a quick revision of what we done in part 1. Keep tuned for the part